In this video, we're going to look at speed and velocity, and we'll explain the difference between what speed and velocity is. We'll learn how to calculate average speed and average velocity, and we'll start looking at some graphs of different types of motion. So let's first look at speed. V average, or our average speed, is the total distance traveled divided by the total time to travel that distance. So we are talking about distance here. So distance is a scalar quantity. So we're not going to have any directions when we are talking about speed. And time can never have directions. Time is always a scalar quantity. And our usual units that we're going to use in physics are usually meters per second. So we're going to look a little bit later in the video at how to convert from, say, kilometers per hour to meters per second. So if we go back to our formula, so our formula is always our V average. We often don't write the AV when we're writing down our formula, is the total distance traveled divided by the total time. Let's look at an example. So we have a greyhound that can run 20.1 meters per second. So that's our V average. So 20.1 meters per second. And we're being asked to figure out how long. So we're being asked for our delta T, and we're told the track is 400 meters. So we're going to write down our given information. So we don't have any direction, so that's how we know we're talking about speed, and you're going to see that velocity really is the same, only it's a vector quantity. So if we don't have direction, we're just talking about speed. So let's write down our formula. So V equals delta D over delta T. And we are going to rearrange this formula to isolate delta T. So first thing we're going to do is multiply both sides by delta T. Again, there are other ways to rearrange formulas. I'm just going to go through all of the steps. So then that would look like that simplified. Again, we want delta T by itself, so we divide both sides by V. So our formula is delta T equals delta D over our V. So now we're ready to put our information in. So our distance is 400 meters, and our speed is 20.1 meters per second, and you type that in on your calculator, and we're going to round our answer to 3 significant digits, so you get 19.9 seconds. So that greyhound makes one lap of a 400 meter track in 19.9 seconds, assuming that it maintains its speed of 20.1 meters per second. So that's just a basic speed calculation. Obviously, we can solve for delta D, or we can be solving for V. I'm showing you one variation of the equation. So now let's look at that example where we're converting from kilometers per hour to meters per second, because this could come to play in some of the lessons that you're doing when you're doing your homework questions. Again, there are lots of different ways to do unit conversions. I like to look at it as, how do I get my units to cancel? So what I'm going to do is I'm going to write my 100 kilometers, and my per hour, I'm actually going to make it like a whole fraction. So 100 kilometers in 1 hour. And then I'm going to start. So I want to go to meters, and I know there are 1,000 meters in 1 kilometer. So we can put the 1 in there for the hour too if you'd like. And then for how many seconds are in an hour, so you have 60 seconds in a minute, and you have 60 minutes in an hour. So that gives you 3,600 seconds in 1 hour. So if you write down all of those kind of different unit conversions, and then we look. So when we're doing this, we look at, I'm going to call this our dividing line. Okay, so it's the line in the middle. So if your units are on opposite sides, so kilometers here are on opposite sides. So when they're on opposite sides, we multiply to get them to cancel, because you're dividing. So if you divide a kilometer by a kilometer, they cancel out. When they're on the same side, like they are in the case of the hours, we divide. So then on your calculator, you would do 100 times 1,000, hit your equal sign or be using brackets, and divide by 3,600. And we get 27.8 seconds. So that's how I do my unit conversions. There are other ways to do it. As long as you can show some steps and show me how you get that, then that's fine too. So now let's look at average velocity. So velocity is the average displacement. So remember, displacement is always has a direction because it's a vector quantity. So now we're talking about speed with a direction. That's basically what velocity is. So the formula looks pretty much the same, only we've added the arrows because we're talking about vector quantities. So we're doing the displacement divided by the time to figure out our velocity. We're also going to start looking at some graphs. So if we have a position time graph, position, remember, is pretty much the same as displacement. Your displacement is your total position, change in position. The slope of a position time graph will give us the velocity. Look at for our example, rather than just looking at the math, let's look at a graph. So we're going to determine the average velocity from the given position time graph. I'm going to add in my direction because they're not here. So let's assume it's in the east direction. Your graph should tell you what direction it is. The one that I pulled from the internet just didn't have that direction. So let's just assume it's in the east direction. So we're going to calculate the slope. So this should bring back memories of grade 9 math class. So we're going to choose 2 points, and our slope formula is y2 minus y1 over x2 minus x1, or you can count the blocks if you'd like. So just the triangle that I've drawn, I'm going to do 20 meters, subtract 10 meters, and then I've got 4 seconds minus 2 seconds. I'm just going to simplify that for you. So we get 10 meters and 2 seconds. So our slope is 10 divided by 2, sorry. Let me just erase that, is 5. And then our units are going to be meters per second. And then we're going to tack on the east direction. So that is, in fact, a velocity. So if you have a position time graph, when you divide to figure out your slope, you're going to end up with units of meters per second. Meters per second is either going to represent a speed or a velocity. And because we've used a position time graph, position time graphs, that is a vector quantity, so we are going to have a direction. So that's why I've put the arrow over top of my V, because it is a velocity. So just looking at graphs a little bit further, because we're going to be looking at these more throughout the unit, you're going to have either straight lines, so linear relationships, and that means you have a constant velocity, so no acceleration. And the math is a little bit easier if we assume no acceleration, but sometimes we are going to have to look at accelerated motion. And so a non-uniform position time graph, so something that's accelerating, is going to have a curved line, and that should make sense to you because as you are increasing your velocity, you are traveling further away in less amount of time. Again, we will look at those later in the unit just to kind of give you a little sneak peek. So that brings us to the end of the video. So hopefully you can tell the difference and explain the difference between speed and velocity. You should be able to calculate. I know we only did one example, but it's pretty easy 3-part formula, so you should be good to go for the others. And you should be able to relate some graphs to their type of motion.